NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again, after months of spouting gibberish.
In the cold, empty silence beyond our solar system, Voyager 1 just sent back a signal no one expected, one that defies everything we thought we knew about deep space. Launched nearly 4 decades ago, this tiny probe has crossed into interstellar space, beyond planets, beyond light, and now possibly beyond explanation. What exactly did Voyager 1 encounter out there? Scientists are baffled, data is being reanalyzed, and speculation is running wild. Is this just a glitch, or the first sign that we're not alone in the void? Buckle up, this may change space exploration forever. Voyager 1's encounter with the unknown. Voyager 1, a remarkable relic of human exploration, recently became the first man-made object to leave the solar system, venturing far beyond the outer planets into the vast and uncharted expanse of interstellar space. Launched in 1977, with the primary goal of exploring the outer planets, Voyager 1 long ago surpassed its original mission and entered into the realm of scientific enigma. Yet, it was the data it gathered on its way through the interstellar void that left scientists reeling. Voyager 1 crossed the heliopause, the boundary where the sun's influence wanes and the interstellar medium begins, in 2012. Since that historic milestone, the probe has continued its journey, delivering unprecedented data that challenges current scientific understanding. It has measured fluctuations in cosmic rays, magnetic fields, and plasma waves, shedding light on the intricate and complex nature of the interstellar medium. But it wasn't until recently that the spacecraft experienced an event so perplexing it could potentially reshape the entire way we perceive the cosmos. What happened to Voyager 1 out there, billions of miles from Earth, goes beyond the conventional understanding of space and physics. A mysterious and unexplainable burst of energy occurred, one that did not match any known cosmic phenomenon. It wasn't just a spike in cosmic rays or a minor fluctuation in the plasma density. The anomaly had a distinct pattern. The entire event, lasting for several hours, had a significant impact on the spacecraft's systems, altering its gyroscopic readings, disrupting its telemetry, and even triggering the spacecraft's fault protection systems. When the data from Voyager 1's anomaly first reached Earth, the initial assumption was that it was caused by a glitch in the spacecraft's hardware. Voyager 1, now nearly 50 years old, was far beyond its intended operational lifespan. Yet, when the spacecraft's systems returned to normal and no signs of physical damage were found, the mystery deepened. The anomaly was not caused by a malfunction of any onboard component, but rather a high-intensity, structured energy burst that appeared to modulate across frequencies, something never before observed in interstellar space. This burst was not random. It exhibited a pattern, much like a waveform, but with a level of coherence and intensity that defies natural phenomena known to science. The probe was alone in this remote region of space, and no nearby objects or cosmic events could explain the disturbance. There were no gamma-ray bursts, no supernova shockwaves, no black hole interactions, nothing that could account for such a precise and focused energy event. The most astonishing part of this anomaly was that it seemed to have a directed quality, as though the energy was coming from a specific source in space. For several hours, Voyager 1 experienced the burst, which seemed to nudge the spacecraft slightly. Its orientation shifted, but only for a brief moment. The spacecraft's gyroscopes picked up this minor torque, an almost imperceptible spin that lasted long enough to register on diagnostic systems. However, there was no known external gravitational influence that could explain this. It was as if the spacecraft had been gently pushed or nudged by an unseen force. Even more curious was the signal transmission time, which is typically delayed by over 22 hours, due to the vast distance between Earth and Voyager 1. During the anomaly, however, engineers noticed that the signal returned slightly faster than expected, indicating some kind of distortion in the surrounding space-time environment. This could be a clue that Voyager 1 had passed through a micro-warp or a localized distortion in space-time, a concept straight out of science fiction but rooted in theoretical physics. Theories and speculations. What did Voyager encounter? The scientific community has been grappling with the implications of this anomaly ever since it was detected. Various theories have emerged, from plausible to extraordinary, each attempting to explain the unusual energy burst that Voyager 1 recorded. One possibility is that Voyager 1 encountered a high-energy plasma filament, part of the magnetic structures that exist throughout the Milky Way. These magnetic filaments could potentially cause fluctuations in energy that would affect the spacecraft's systems. However, this theory doesn't fully account for the highly structured nature of the energy burst or its directed quality. Another theory, more speculative in nature, suggests that Voyager 1 may have crossed paths with an unknown technological construct or signal source, potentially even of alien origin. This idea, while thrilling and captivating, has been met with skepticism within the scientific community. The idea of encountering extraterrestrial technology raises profound questions, but without more evidence, it remains a tantalizing, unprovable hypothesis. A third possibility points to quantum field effects in interstellar space. Some researchers believe that Voyager 1 might have experienced fluctuations in the zero-point field, a quantum vacuum energy that exists even in the absence of particles or radiation. These fluctuations are typically too small to be measurable, but in rare instances, they could potentially manifest as detectable disturbances. If true, this would imply that Voyager 1 encountered an event that was far beyond current understanding of space physics. While all these theories remain unproven, the implications of the anomaly are immense. If Voyager 1 did, in fact, encounter something beyond the limits of human understanding, it could represent one of the most significant discoveries in space exploration. It would force scientists to rethink the nature of the universe itself, and perhaps offer a glimpse into realms that are currently beyond our ability to comprehend. The silent messenger of the unknown. Voyager 1's journey through the cosmos has always been a symbol of human perseverance and curiosity, but its recent encounter with an inexplicable anomaly has raised more questions than answers. Voyager 1, which has been traveling through one of the most pristine environments in the galaxy, might have brushed against something far beyond our current understanding of space. The concept of voids in the interstellar medium, regions of space that might harbor energetic fault lines or instabilities, has fascinated scientists. But this anomaly suggests that space might not be the passive, empty expanse we once believed it to be. Could space itself harbor mysteries we have yet to uncover? As Voyager 1 drifts farther into the interstellar void, the nature of its mysterious encounter hints at the existence of cosmic phenomena that remain hidden from us. This event might be a clue, pointing toward forces that defy current scientific understanding, forces that challenge the laws of physics we so confidently rely upon. What we know for sure is that the energy burst Voyager 1 recorded was not just a random fluctuation in cosmic rays or a typical disturbance in plasma. The pulse was structured, patterned in a way that hints at an intelligent source, or, at the very least, a non-random cause. The idea that we could be encountering interstellar messaging, something alien or technologically advanced, sends chills through the scientific community. Could Voyager 1 have inadvertently passed through the edge of an interstellar beacon? Was this event a faint whisper from long-dead civilizations, echoing through the fabric of space and time? The possibility raises questions about communication and intelligence that span the stars. The strange pulse, a glimpse into another reality. Scientists have begun analyzing the anomalous data using advanced Fourier transforms and pattern recognition algorithms, hoping to decode what might be the first interstellar message ever received. The rhythmic modulations in the signal don't resemble any known communication pattern, human language, or mathematical constant. Yet, the mere existence of patterning implies intent, an intentional design or guiding mechanism beyond the typical natural events we've observed in space. Could this pulse be a message, or perhaps a fragment of something much larger, something that we can't yet comprehend? Voyager 1's unexpected brush with this anomaly opens up tantalizing possibilities about the way communication could occur in the vast expanse of the cosmos. If this truly is an attempt at interstellar messaging, it would signify a massive leap in our understanding of the universe and possibly our place in it. What if we're standing on the precipice of discovering the first tangible evidence of intelligent life beyond Earth? But how likely is it that Voyager 1 encountered such a message? Could this event simply be a statistical fluke, a natural anomaly that coincidentally resembled patterns we've associated with intelligent design? The idea that a spacecraft could stumble upon an active signal or encounter a phenomenon that we don't yet know how to interpret challenges the very boundaries of our current knowledge. A new understanding of space-time? Perhaps the most profound implication of this anomaly is the potential that Voyager 1 passed through a region where the laws of physics behave differently. If Voyager encountered a pocket of space where gravity, light speed, or electromagnetism momentarily fluctuated, then our understanding of cosmology could be incomplete, or at least context-dependent. This would point toward the existence of bubbles, of altered physics, areas of space where our traditional physical laws may not apply. Could Voyager 1 have wandered into one of these anomalous zones, where the normal rules of physics briefly broke down? The possibility that certain regions of space allow the laws of physics to shift, allowing for the manipulation of time, space, or energy, stretches the limits of our imagination. For years, theoretical models of string theory and quantum gravity have allowed for the possibility of such anomalies, and Voyager 1's encounter may be the first observational evidence of such exotic phenomena. Could this be our first peek into a universe that operates beyond the 4 dimensions we are familiar with? Moreover, the pulse's self-organizing nature and lack of conventional energy source raises further questions about its origins. The very fact that the energy burst appeared to focus and direct itself challenges everything we know about how energy propagates through space. It was almost as though the spacecraft had come into contact with something capable of manipulating its surroundings, not just the space around it, but the very fabric of space-time itself. Could this be evidence of an interdimensional encounter, a fleeting moment in which Voyager 1 brushed against a layer of reality that we are not equipped to perceive? The implications of Voyager 1's encounter are vast and exciting, yet undeniably unsettling. Could the spacecraft's unexpected experience mark the beginning of a new chapter in our understanding of the universe? Or could it simply be the first of many anomalies to come as humanity extends its reach deeper into the unknown? The idea that Voyager 1 might have encountered something not just beyond our physical reach, but beyond our intellectual comprehension, suggests that we have only just begun to scratch the surface of the true nature of the cosmos. Voyager 1's continued journey through interstellar space serves as a reminder of the immense vastness and mystery that surrounds us. Its data, now more valuable than ever, might hold the key to understanding some of the most fundamental questions about our existence, space-time, and the very fabric of reality. The anomaly could be a glimpse into something far greater, something that challenges our basic assumptions about the universe and humanity's place within it. As Voyager 1 continues its journey further into the unknown, its mysterious encounter might serve as the catalyst for a new wave of scientific exploration. Scientists are already considering the possibility of sending probes to investigate the region Voyager 1 now occupies, armed with more advanced instruments and faster propulsion systems. With the chance to study this strange space more closely, humanity could finally unlock the mysteries that Voyager 1 encountered. Voyager 1's legacy is no longer just about the data it has already sent back from its journey. It may now also include the discovery of an entirely new frontier in our understanding of the cosmos. For decades, this spacecraft has served as humanity's scout into the depths of space. As it continues its voyage through the great unknown, one thing is clear: the universe still has many surprises left to reveal. Voyager 1, a new frontier in interstellar exploration. Voyager 1, launched in 1977 to explore the outer planets of the solar system, now serves as humanity's first emissary to interstellar space. What was initially designed as a mission to study Jupiter and Saturn has since transcended its original purpose, embarking on a journey that could revolutionize our understanding of the cosmos. Recently, Voyager 1 encountered an event that defies conventional scientific understanding, leading researchers to reconsider what we know about space itself and the very nature of our universe. Voyager 1's anomalous encounter occurred in a region of interstellar space where we previously believed there was nothing but emptiness. The disturbance recorded by Voyager wasn't just another cosmic ray or fluctuation in plasma density, it was an energetic anomaly that has led scientists to re-evaluate the fundamental assumptions they've held about the universe. Was this disturbance caused by an undetected cosmic event, or could this be evidence of something entirely new, a hidden force or phenomenon beyond our current scientific models? The first major question this anomaly raises concerns the interstellar medium, the vast, seemingly empty void that separates the stars. For centuries, scientists have assumed that this region is simply a sparse, ionized sea of particles and magnetic turbulence. But the event Voyager 1 recorded challenges this assumption, suggesting that there may be hidden structures within this space, structures that remain undetectable by conventional detection methods. What if interstellar space isn't empty at all? What if it is populated by pockets of complexity, hidden energetic geometries, or even unknown matter states? These ideas suggest a far more intricate and dynamic reality than what we have imagined. It's possible that Voyager 1 passed through an area where the energetic topography of space itself is structured, perhaps similar to how terrestrial landscapes are shaped by mountains, valleys, and fault lines. Interstellar beacons and hidden structures. The energy burst recorded by Voyager 1 wasn't just random or diffuse. It had a specific directional quality that strongly suggests an intentional source. Could Voyager 1 have accidentally encountered an interstellar beacon, a kind of cosmic signaling mechanism used by distant civilizations or phenomena? The possibility that this anomaly was a form of communication, or at least a signal embedded in the interstellar medium, opens up a world of speculation. Could it be a message from an ancient civilization or a technological artifact left behind by some unknown force? These questions push the boundaries of what we thought possible. If this is indeed an interstellar communications system, it might be a relic of galactic events long past. Or perhaps it's an ongoing transmission from a civilization far older than our own. Some theorists propose that the burst could be a signal from a civilization that has long since disappeared, its communications still reverberating through the cosmos like radio ghosts. Others suggest that it could be an example of advanced technology, perhaps even beyond our current comprehension. The idea that Voyager 1 could have stumbled upon such a phenomenon raises questions about the possibility of interstellar communication mechanisms that don't rely on traditional radio waves or electromagnetic signals. Adding another layer of intrigue to the anomaly is the theory that the event wasn't simply a passive burst of energy, but rather a response to Voyager 1's presence. Could the energy burst have been triggered by the spacecraft itself? The idea that Voyager 1 might have activated a dormant system, like a motion detector or a tripwire embedded in the galactic substrate, is a fascinating possibility. If this theory is correct, it would suggest that space itself is more interactive than previously imagined, responding to the presence of specific objects, like Voyager 1, that cross its path. This raises questions about the nature of the object or system that could cause such a response. Was Voyager 1 simply in the right place at the right time, or did it somehow activate a hidden cosmic mechanism? The idea that Voyager 1 could trigger an energetic response from a previously unnoticed system suggests that space may contain more secrets than we can currently comprehend, potentially filled with dormant technologies or phenomena waiting to be awakened. Quantum and electromagnetic disturbances, time, space, and beyond. As scientists continue to investigate the anomaly, they are also considering the possibility that the disturbance may be related to quantum field effects in interstellar space. Quantum fluctuations in the vacuum of space, also known as zero-point energy, are typically too small to be detected. However, some theorists suggest that under certain rare conditions, these fluctuations could become detectable, especially if they interact with a spacecraft in a way that causes measurable effects. This could explain the strange behavior Voyager 1 experienced. In addition to the quantum theories, the anomaly's influence on Voyager's internal systems is also being closely examined. Subtle irregularities in the spacecraft's atomic clocks and timing systems were observed, suggesting that Voyager 1 may have passed through a localized space-time curvature, similar to what we would expect from gravitational lensing or even wormhole-like phenomena. If this hypothesis is confirmed, it would be the first empirical evidence that space-time behaves differently in certain regions of deep space, revealing potential micro-wrinkles or eddies in the fabric of the universe. Such findings could revolutionize how we think about space travel. If regions of space can alter time perception, even subtly, future missions will need to account for these variations when plotting trajectories, designing spacecraft, or even managing the biological effects on astronauts. The discovery of these temporal anomalies could also open the door to a new understanding of chronodynamics, the study of how time behaves in different parts of the universe. Even more intriguing are the electromagnetic fluctuations that Voyager 1 recorded. These low-frequency anomalies appeared both before and after the primary event, suggesting that the spacecraft passed through a wake or disturbance left by some unknown phenomenon. This behavior closely resembles the way a boat moves through water, displacing the fluid and leaving behind ripples that continue to propagate after the boat has passed. If Voyager 1 did pass through an invisible field, these wakes might be used to backtrack its path, identifying other areas of space with similar properties. This discovery could lead to a new method of mapping the interstellar medium, one that doesn't rely on traditional astronomical observations, but instead focuses on the subtle disturbances left behind by objects passing through these invisible realms. The wake could serve as a guide, leading future spacecraft to unexplored regions of space that harbor similar phenomena. The anomaly displayed several characteristics that defy conventional explanation. The energy pulse that Voyager 1 encountered appeared to have a focused, beam-like quality. This focused transmission of energy in the depths of space suggests the possibility of some sort of intelligent or natural system beyond the scope of current scientific understanding. Could this energy burst be part of a phenomenon that we have yet to classify? Or could it be evidence of an unknown interstellar communication system? The burst had an organized structure, suggesting that it was not a random cosmic event. This kind of pattern is often associated with intelligent design, though not necessarily with intelligent life as we know it. The fact that the anomaly exhibited a kind of symmetry and mathematical harmony adds an intriguing layer to the mystery. Was this a form of communication, either intentional or accidental? The possibility that Voyager 1 may have encountered an unknown form of interstellar messaging, or even the remnants of an ancient communication network, has captured the imaginations of many in the scientific community. Perhaps the most surprising aspect of the energy pulse is the resonance it carried. Researchers have used advanced Fourier transforms and pattern recognition algorithms to analyze the data from Voyager 1, and they found that the anomaly's energy signature contained resonant frequencies that were mathematically structured and unusually symmetrical. The precise patterns in these frequencies suggest a high level of order, one that doesn't resemble the usual background cosmic radiation or interstellar noise. This discovery has prompted scientists to explore the possibility that Voyager 1 passed through an area where local spacetime behaves differently from the predictable patterns we are used to. Could Voyager 1 have entered a region of space where the fabric of spacetime is influenced by forces or structures that we have yet to recognize? If so, the anomaly may mark the first instance of humanity encountering such a phenomenon, a physical manifestation of a layer of reality that we are only beginning to comprehend. Theories of interstellar communication, or hidden structures. The idea that Voyager 1 might have passed through an interstellar beacon, or a region of space with a hidden coherent energy structure, opens the door to some fascinating possibilities. These anomalies might be relics of long-gone civilizations, or they could be part of an entirely natural yet previously unknown phenomenon within the interstellar medium. The idea that the universe could be alive with hidden energetic topographies, complex fields that remain undetectable to conventional methods, suggests that space is far from the barren, empty void we once thought it to be. Some theories propose that the energy pulse Voyager 1 detected might be part of a long-range communication system, an interstellar network that spans vast distances across the galaxy. Whether these pulses are signals from distant civilizations or remnants of ancient natural events, the potential for discovering such a system represents a paradigm shift in how we understand the cosmos. Another compelling possibility raised by this anomaly is that Voyager 1 may have encountered a temporary distortion in space-time itself. The spacecraft's trajectory data indicated a subtle deceleration, something so minor it was barely noticeable, but statistically significant over time. The deceleration could suggest that Voyager 1 passed through a region of space with unusual properties, perhaps a localized pocket where space-time behaves differently. This is not merely a hypothetical situation. It could be the first observable evidence that deep space is not the uniform and static region we once assumed. In this light, the anomaly may offer a glimpse into a new type of physics, one that could radically alter our understanding of time and space. If Voyager 1 did pass through a temporary pocket of altered space-time, this could mean that certain regions of interstellar space are capable of bending or distorting the laws of physics as we know them. Such a discovery would force us to reconsider the very nature of space travel, requiring entirely new models of physics to account for these localized distortions. Quantum interactions and space-time warping, a new model for space travel. The idea of localized space-time distortions raises exciting possibilities for future space exploration. If certain regions of space can experience variations in the fundamental constants of physics, such as the speed of light, gravitational force, or electromagnetic interactions, then space travel could look vastly different from what we envision today. Space missions could eventually need to account for regions where the normal rules break down, potentially affecting everything from navigation to the health of astronauts. Furthermore, if space itself can experience fluctuations that momentarily alter its properties, this might allow for new forms of propulsion or energy transmission. Scientists are already exploring the idea of using quantum field effects for faster-than-light communication or travel. The anomaly Voyager 1 encountered could be an early hint that such possibilities are more than just theoretical concepts, providing a potential stepping stone for the future of interstellar exploration. As researchers continue to study the data from Voyager 1, the scientific community is actively exploring multiple avenues of inquiry. One promising direction involves modeling the anomaly as part of a larger, more complex system that operates across the galaxy. This could involve mapping the interstellar medium and identifying regions where space-time behaves differently, offering clues about the hidden structures of the universe. As our understanding of space, matter, and energy expands, it's becoming increasingly clear that the universe holds more mysteries than we can currently comprehend. The discovery made by Voyager 1 could be the first of many that challenge our existing models of reality, pushing us to reimagine what is possible in the cosmos. Whether these anomalies are the result of interstellar phenomena, advanced technologies, or some combination of both, one thing is certain: the frontier of deep space is far stranger than we ever imagined. Adding yet another dimension to the mystery is the psychological reaction among researchers who have found themselves drawn to the data not simply through analysis, but through intuition. Several scientists report an almost visceral sense of strangeness while passing the telemetry, an uncanny sensation that they are looking at something fundamentally other, something that resists full comprehension, not just due to lack of data, but due to some form of cognitive dissonance. This kind of response is rare in empirical research, where data is usually cold and neutral. Yet here, the numbers seem to echo with depth, like a pattern glimpsed in the corner of the eye, real and yet elusive. This hints at a new challenge, that some phenomena may not just be physically complex, but epistemically alien, defying the architecture of human perception and logic. The role of Voyager 1's golden record has also come under renewed scrutiny, not in terms of its message, but its physical properties. Encased in aluminum and gold, carrying analog data etched in metal grooves, it represents one of the most unique assemblies of matter in deep space. Some theorists have begun to wonder whether the anomaly interacted with the spacecraft because of this artifact. Perhaps the materials or the geometry of the record acted as a passive antenna or resonator for the anomalous field, triggering an event that otherwise would have passed undetected. This opens up a provocative line of thought. What if human artifacts themselves are capable of engaging with the unknown in ways we never anticipated? What if we have already built, accidentally, devices sensitive to phenomena beyond our understanding? Similarly, there's the question of orientation. Voyager 1 is no longer actively steered. Its position in space is largely determined by momentum and small corrective thruster inputs made years ago. That its instruments were pointed just right to capture this event is an astounding coincidence, or possibly not a coincidence at all. Some in the field of astrodynamics are now modeling whether certain alignments, rotational vectors, or trajectories increase the likelihood of such encounters. If so, this may herald a whole new method of space exploration, not just seeking regions of interest, but orienting our instruments philosophically, so to speak, toward the unknown. The anomaly has also rekindled older theoretical frameworks that had fallen out of favor. One such theory is the idea of morphic resonance, a controversial notion that systems remember forms and behaviors across time and space. As we await further data and insights from Voyager 1's journey, one thing is certain: the universe has far more to reveal than we ever thought possible. The anomaly it encountered, while unexplained, may be just the beginning of a much larger narrative, one that stretches across time, space, and perhaps even dimensions we have yet to comprehend. Voyager 1's mission has only just begun, and the mysteries it holds could redefine the way we perceive our place in the universe. What began as a quest to explore the outer planets of our solar system has now evolved into a journey into the unknown, where the boundaries of space and time may no longer adhere to the rules we once thought they did. As Voyager 1 continues its path through the vastness of space, it is paving the way for future generations of explorers who may one day follow in its footsteps, uncovering even greater mysteries in the cosmos. The strange anomaly it encountered serves as a reminder that space is not just a vast, empty void. It is a dynamic, ever-changing environment filled with forces and phenomena that continue to surprise and awe us. As we stand at the edge of this new frontier, one thing is clear: the journey of exploration is far from over. The universe is waiting, and Voyager 1 is leading the way into the unknown. Alright, so that's it for this video, and if you want to watch more amazing content like this, check out some of our other videos.